April 22nd. You know, to most of us, it's probably just another day on the calendar. But in the world of mathematics, this one single date, it's something special, really special. Any idea why?
Well, it's because on this day, and we're talking across different centuries, different countries, a few absolutely brilliant minds were either born or, sadly, passed away, and their work completely changed the world we live in. So let's meet them one by one. Let's really dig into the incredible legacy of April 22nd. Okay, our journey kicks off not with silicon chips or fancy electronics, but with gears and wheels, in a story that's just amazing. I like to call it the clockwork marvel. I mean, we take it for granted, don't we? The calculator on our phone can crunch these massive numbers in like a split second. But have you ever actually stopped and thought about it? Before phones, before computers even existed, how in the world did people deal with really complex calculations? Well, the answer to that question sends us way, way back, all the way to April 22nd, 1592, and introduces us to a man named Wilhelm Schickard. So Schickard invented this incredible machine he called the rekenau, which basically means calculating clock. And get this, using a clever system of gears and wheels, it could automatically add, subtract, multiply, and divide. This was a total game changer. He actually designed it to help out his friend, the famous astronomer Johannes Kepler, with all those ridiculously hard astronomical calculations. So here's the big takeaway. The world's very first calculator wasn't electric at all. It was a genuine clockwork marvel. Okay, we're sticking with April 22nd, but our timeline is about to take a huge leap. We're going to jump forward almost 300 years, moving out of the age of mechanical gears and right into the dawn of the electrical age. All right, on to our second story. This one is all about the secret behind clear sound. And what's so cool is how it connects directly to the music you stream and the calls you make, literally every single day. Just think about it for a second. You're streaming a song, maybe watching a video, and even when your internet connection is kind of slow and laggy, the sound usually stays surprisingly clear, right? How does that even happen? How does the music get through perfectly without all the static and noise? The secret to that little piece of modern magic lies with a man who passed away on April 22nd, 1945, a German mathematician by the name of Wilhelm Cauer. Cauer came up with this revolutionary way to filter electrical signals. Just look at the slide here. On the left, you've got a signal that's just a chaotic mess, full of unwanted noise. But after it goes through one of Cauer's filters, look at the right. You get a clean, clear signal. His filters are like a perfect bouncer at a club. They let the right sound frequencies in, and they block out all the unwanted noise. He literally found a way to separate the music from the chaos. So here's the thing to remember. Every single clear song you stream, every crisp phone call you make, it's all possible today because Wilhelm Cauer figured out how to filter out the chaos. It's that fundamental. So now we've got two major points on our April 22nd timeline. Same date, totally different problems, totally different solutions. But believe me, the story of this date gets even bigger. Let's jump to our next brilliant mind. All right, for this next one, we're going to have to stretch our minds a bit. We're moving beyond things we can touch like clocks and circuits and diving headfirst into the abstract world of shapes that might exist beyond what we can even see or feel. So we live in a 3D world, right? Length, width, height. We get that. But what about the universe itself? Modern physics talks about the possibility of 4, 5, maybe even 11 dimensions. I mean, how on earth does a mathematician even begin to describe the shape of something like that? Well, the genius who took on that exact question was born on April 22nd, 1929. Meet Sir Michael Atiyah, a winner of the Fields Medal, which is basically the Nobel Prize for mathematics. Atiyah's work was in these super complex fields called geometry and topology. Now, to put it really simply, he basically created a new kind of mathematical language, a new toolkit. This toolkit gave physicists a way to describe the fundamental building blocks of our universe. He's the guy who built the bridge connecting the pure, beautiful world of abstract math to the mind-bending realities of theoretical physics, like string theory. His work helps us ask the biggest question of all: what is the actual shape of our reality? Isn't this incredible? One single date. From mechanical calculators to clean audio to the very shape of the cosmos. The story of April 22nd is just amazing. But we have one more stop to make. And this next story,
It's just pure inspiration. Let's meet our final trailblazer.
And now, we come to a story that's deeply inspiring. It's all about breaking barriers, defying expectations, and changing the game. Think about this. In a time and in a place where women just weren't really expected to pursue careers, especially in science, how did one young woman from Madras, India, manage to become a world-renowned mathematician? The answer is Bhama Srinivasan, who was born on April 22nd, 1935, right there in what was then called Madras, India. And this quote right here, it just perfectly sums up the kinds of challenges she was up against. A well-meaning friend actually said this to her once. "It is a pity you don't have children, but isn't it wonderful that you have something to keep you occupied?" Can you imagine? But in the face of attitudes like that, she didn't just have something to keep her occupied. She became a leading figure in a deeply complex field of math and even served as the president of the Association for Women in Mathematics. A true inspiration. So there you have it. From a 16th century mechanical inventor to a 20th century trailblazer. Everyone we've met today, separated by hundreds of years and thousands of miles, was ultimately driven by the very same deep, fundamental question. That one question was this: what is the pattern hiding inside the chaos? And because they dared to ask it, because they looked at the mess of numbers or signals or theories or society and searched for the hidden order, we now have calculators in our pockets, we have crystal clear audio, we have a deeper understanding of our universe, and we have incredible role models to look up to. So the next time you use a calculator or you put on your favorite song, maybe just take